Hello everyone and welcome to this webinar dedicated on the design to the sustainable riverbank protection. I'm Antoine Gagliardi, head of Double Twist business unit at Macaferri Group. I'm pleased to start this webinar on Rhino Mattress Plus. I will be followed by Paolo Di Pietro, technical manager at Macaferri with over 35 years of experience in the river hydraulics. The presentation will last 45 minutes and at the end of the webinar, we'll be running a live Q&A session, so we have enabled our Ask a Question feature. It is on the right-hand side of your screen, so if you have any questions, just drop them in there. Macaferri's commitment in hydraulics started way back in the 19th century. For over 130 years, we have been developing natural solutions that enhance ecosystem resilience, including the social ability to recover quickly from catastrophic events. We did it from the very first application in 1893 along the river Reno in Italy. About 130 years later, the solution we designed and manufactured is still there, retaining the riverbank and perfectly integrated into the surrounding environment. Rhino Mattress, one of our most common solutions, was named after this first intervention. Today, the term Rhino Mattress is synonymous with hydraulic works and erosion protection projects worldwide. Today, we are here to promote once again a design approach that considers the long-term impact of river work, including the economical and social benefits. I thank all of you again for joining this webinar. I will leave you to a brief video followed by the presentation on a design case developed with Macra software. Let's design the change together.
The hydraulics laboratories of Colorado State University in Denver and Sogea in Grenoble have carried out studies on both reduced and full-scale models to improve the design of Rhino mattress revetments.
Thank you, Antoine, for the introduction. Good day to everybody and welcome to this webinar session. Macra Studio 1.5 is a user-friendly tool developed to assist designers in the selections of most appropriate anti-erosion systems for bank protection. As we will see, the software enables to perform a risk assessment by viewing different scenarios with multiple choices, pulling out from a database the shear resistance values for several anti-erosion systems. The software has a graphic interface which allows to model the geometry of channel sections, assigning either natural materials, bare soils or vegetation from light to dense, or erosion protection systems to each segment. We will see how results allow designers to quickly make a decision of the effect of a flood, considering the various scenarios. What we're going to see today is a real-life case of a river training work, where we will perform a risk assessment using our software to provide a sound engineering solution for a river stretch about 1 kilometer long. In our real-life case, we start from the analysis of the river segment, which runs in a relatively flat and open area. The river shows the tendency to meander in this area, as we recognize from the historical satellite views. Here we can see a more clear image obtained in 2013 of the same segment. Although in the first years of observation we could not see relevant changes in morphology, probably due to the relatively dry seasons in between, a flood which hit in 2013 caused some erosion on the left bank, moving towards the property line quite significantly. As you can see, this is the property line. We can see from the map a first local intervention to recover the land by recreating an embankment and backfilling the eroded area. Unfortunately, though, this intervention, although simple and requiring small investments, cannot be sufficient to resolve the problem, as we will see next. During the following years, in fact, the river regained the space towards the property line by washing the embankment off. From Google Image in 2018, we can recognize 3 groins, probably part of a second intervention in an attempt to recover the lost land, moving the river back to its original shape. In the same year, both the landowners and the road authority decided to invest in an urban infrastructure development by rehabilitating the secondary road running along the property line, building a new house and a parking lot in this area, and moreover, making a new road and a bridge crossing the river. Given the challenges, this infrastructure development project required an in-depth feasibility study of the area to ensure that all this could be built in a safe environment with a reduced risk of further erosion and scour. So the first step was to draw a detailed survey of the area. Here we can see the layout of the river segment, approximately, like I said, it's 1 kilometer long. The identification of 4 typical representative sections at station 0, beginning of the segment, station 400, downstream from the new bridge, station 600 along the bend, and a 900 at the last section. Finally, a longitudinal profile of the river segment, showing gradients and location of the bridge, as we can see here. The hydraulic data required to study the effect of 2 possible events. One, with a return period of 25 years, corresponding to an 800 cubic meters per second design discharge. And a second one, corresponding to the 100 years major flood event, for which the hydrologic studies provided the value of 2,100 cubic meters per second. So we started analyzing station 0, which is the entry section. In this section, the river runs fairly regular through the section. The tailwater curve shows that in both conditions, 800 cubic meters, as well as the 2,100, the flow runs within the size of the banks and the freeboard. However, with the 100 years flood event, the calculation shows that the natural soil present in the river is subject to a uniform erosion, a bit all across the section. The uniform erosion along the straight section is, though, relatively simple to manage, assuming that the duration of the 100 years flood is normally not as long as the more frequent 25 years flood. The important factor in such a situation is making sure that the flow runs in the central part of the river, keeping the banks stable. So the solutions adopted included the Rhinometris Plus to ensure the stability of the banks and the berms. The cross-section at station 400 poses an additional problem, the presence of a new structure, the bridge. To this purpose, the cross-section was selected right downstream the location of the bridge. Here again, the tailwater curve is telling us that both the 800 and the 2,100 cubic meters per second discharge will still be contained inside the bank full section area. So both conditions were fine. However, as expected, under the major event, the 2,100 cubic meters discharge, all cross-section segments are subject to the erosion, in a similar fashion as done for section at station 0. Here we shall protect the banks in a way to keep the discharge and the erosion in the central part of the section. So same as done at station 0, solutions will be to protect the left side of the berms, this time with a mass gravity gabion wall, because of the, say, inclination, the slope of the banks here, and a Rhinometris Plus on the right side. Being this section wider than the previous one, the upper bank on the right-hand side will also require a mattress protection to prevent scour and outflanking effects, which could destabilize the bridge piers. As far as the exact position and extension of the Rhinometris Plus, decisions obviously will depend on the type of bridge and more specifically on the location of the piers. So this is an example case where we can show an approximate location of the protection areas that need to be taken care of. Cross-section at station 600 requires to redirect the river, controlling the meandering effect. Again, the tailwater curve is giving us good information, telling that the 800 and both the 2,100, so the peak flood, are still inside the upper banks. Here again, we can see that all sections are subject to an erosion, uniform, during the 100 years flood event. However, this time, the erosion protection shall be aimed at moving the flow towards the right side to avoid further progressive scour on this side, on the left side. So the bank protection will consist, in this case, in a gabion retaining structure here, combined with a mattress apron and a battery of groins on the left side, and a Rhinometris Plus on the right side. The software in this case will not conservatively include the presence of the groins in the calculation, since they require a specific design, length, distance apart, etc. We now move to the last section, which is station 900. We could say that this section returned to the regular straight flow regime with a typical double trapezoidal shape and a low flow area containing the 25 years flood, as well as the bank full containing the 100 years major event. So what we need to check in this zone is that the flow regime is now back to normal. Since conditions and flow regime haven't changed, the first run with the 2,100 cubic meters tells us that all segments, are in erosion. However, again, Rhino Mattress Plus protects the lower banks, and this will be sufficient to reestablish the linearity, allowing the flow to run in the central part of the section where the erosion will not cause any troubles. In summary, we have seen 4 situations, fairly different, at station 0, 400, 600, and 900, facing different challenges. At station 0 and 900, we needed to keep an alignment. At station 400, we needed to protect the bridge. Station 600, we needed to control the meandering effects. So these 4 requirements find a common solution if we can look at the project from a spatial point of view, moving from one station to the next one in a sort of integrated approach. The software was able to provide us with all necessary details to make these choices and to perform a risk assessment. Central section, protecting one side, pushing the river to the other side. Clearly, the software is now replacing any engineering judgment and the experience. However, the user-friendly interface allows designers to make this job simple to accomplish. We have seen a simulation based on a realistic scenario. In order to provide a stable and sound solution, we use the Rhino Mattress Plus. Rhino Mattress Plus are particularly suitable for bank protection. After being tested at Colorado State University in 2019, in accordance with the American standard ASTM D6460, common to most erosion control products. Now we can design the new Rhino Mattress Plus to withstand much higher stresses than with conventional mattresses. This leads to an overall reduction in the cost of ownership, as we will see. We provide regular trainings for the software for people interested in using this tool. Those of you interested in having the software may request the download, let's say, by typing the word software in the chat box, and we will send it to you. If you wish to download other supporting material, please click on the document folder where you can find the information. Rhino Mattress Plus with the X ties have basically 3 main improvements compared to conventional mattresses. Number 1 is the pleating of the mesh, making the partitions much more robust with the double mesh. The second is the innovative and much more durable new polymer, Polymac, making the wire more resistant to abrasion, to the abrasive effects carried by the flow, but also a higher UV resistance to the high temperature, as well as a much lower embrittlement temperature in the cold climates. And finally, the X ties to firmly and securely connect the lid to the bottom of the mattress. X ties are freestanding tools, and this makes them particularly easy to install. They considerably improve the structural performance of the mattress against the flow, preventing the movement of stones. How do we define the total cost of ownership, as I mentioned earlier, for bank protections? Well, the total cost of ownership includes all costs related to a structure over the time. They can be split in short-term and long-term costs. In short terms, costs will be for purchasing materials, steel mesh, stones, and for installing the structure. In long terms, costs will be direct for maintenance and indirect for the integration with the surrounding environment. Using less materials, enabling faster installation, and leading to greener results will meet our target to reduce the total cost of ownership. For what concerns the material reduction, let us consider the three options when we deal with design of a riverbank protection: the loose stone riprap, standard mattress, and the Rhino Mattress Plus. We already have a significant reduction cost going from the loose stones to the standard mattress, thanks to the benefit of the confinement of the stone and the confinement that the stone brings in. The introduction of the X-Ties gives the Rhino Mattress Plus performance that dramatically reduces the thickness of the bank protection even more. In particular, under the high velocity flows, benefits are even more relevant. Beside the endurance in performance during the event, being the stones confined inside the mattress cells, Rhino mattress structures require minimal maintenance over the years. On the contrary, riprap protections made by loose stones of large size tended to be either washed away by the flood or to sink into the soft soils, requiring, in both cases, a field replacement with one or more layers. The second advantage, making our Rhino Mattress Plus an attractive alternative, is the environmental burden reduction compared to traditional systems. In the construction of a riverbank protection, Rhino Mattress Plus generate a very low CO2 emission compared to riprap or even standard mattresses in high flow regimes. The values shown have been obtained by the EPD, which is the Environmental Product Declaration. There is a chart showing the amount of kilograms of CO2 in relationship to the shear stress regime generated by the flow in a river environment. For those not familiar with the EPD, an environmental product declaration is defined by ISO 14025, in Europe by EN 15804, and it quantifies environmental information on the life cycle of a product to enable comparisons between products fulfilling the same function. The EPD methodology is based on the life cycle assessment, which is a tool that follows ISO 14040. According to the values provided by EPD, by increasing the shear stress, hence the flow regime, the thickness of the protection as well as the CO2 emissions increase. By observing the natural recovery of the environment as built and after years, we notice the benefit of natural integration. By mentioning that Rhino mattresses allow living species to find them in habitat, we forgot to mention the benthos organisms, a large community of organisms living near the river who are fundamental elements of the biodiversity chain. The third major benefit is the installation reduction time. Rhino Mattress Plus speed up on-site operations for two main reasons. The first one, as I mentioned, is the self-standing tie developed to make the installation easier and to improve the structural performance of the mattress. Here we can see an example case showing how this tool works out in the field. Quite simple to use and to let's say, put it in place during installation. The robust and double diaphragm is the second important feature, enabling fast installation, especially on the steep slopes and minimizing installation inaccuracies. We now are going to take a quick look at an installation video to show you these operations that I just mentioned here. Well, we showed a series of tested performance concerning the new Rhinometris Plus. As last point to mention, beside the environmental and digital certifications of this product, another important point is the BBA approved BIM object. It may be worth to spend a word for BIM. Building information modeling has received an increased attention in the construction sector. BIM is becoming a widespread and common approach in design, construction and maintenance of infrastructures. Nowadays, the use of BIM is ever growing in many countries. Engineers can easily access a library of certified products and pull out their characteristics from a database included in the drawing. McAfee is a wide gallery of products already available in our BIM store. Well, as a conclusion on this brief presentation, I'd like to mention what we have learned. As engineers, river engineering shall take into account two types of requirements when designing the solution. So it is very important to keep all in our mind, of course, starting from the hydraulic requirements. Geotechnical and hydraulic stability obviously is one of our primary concerns, what we learned from our studies. Providing sound engineering principles, which is very, very basic of our knowledge in river engineering. Using design criteria based on the risk assessment, as we have seen in this example case. And finally, not to forget that the erosion will impact on the environment. So considering erosion as a fundamental evolution of our environment. And this is the part that we all learned from school. But the other important factor that today is becoming a major part of the modern engineering is to keep in mind the environmental requirements. The river is a dynamic environment. We need to introduce a minimal disturbance when we apply products for river bank protection. We need to use systems which will help the environment to sustain. And finally, we need to balance the ecosystems in a proper way. If you need any assistance for your project, please type in the chat box. We will be glad to help you. Hold on a second here. This will be fundamental for us to stay in touch with you, to help you out in your, say, future project challenges, and we'll be more than happy. Our technical departments, our engineering staff will be very glad to stay with you on your projects. Well, we thank you for your time, and now I'd like to give time to a Q&A session. So let us now move to our last part of the webinar. I'll be glad to answer any of your questions. Let's see. Okay. Okay, so the one question is if we are present in Latin America. Yes, of course we are, and we're present actually in many countries. You just need to contact our McAfee International website to get your direct address to the office location where we can be of help locally with you. Ooh, I see a lot of questions here. I'll try to answer as I can. But besides, there will be obviously a follow-up session where we will be able to help you by answering questions by emails. Anyway, for all of you registered to this webinar, it will be a free service. Then, of course, we'll be more than happy to follow up. Would gabions and matrices need to be installed underwater? That's obviously another important point in river applications. Yes, they can be installed underwater. There are special techniques to, let's say, install under the conditions on underwater, under the water level. Each project is by itself a specific project case, And that's why we have a specialized staff to assist in the definition of what are the conditions for an installation underwater. So the answer is, of course, yes. In your question, there is another question. Yes, X-Ties shown bring a 20% faster installation on slopes. What about installation on a flat surface? It is more or less what we have tried. We have tried that actually to use the X-Ties as a trial to measure the distance, the differences in time, both on slopes and on flat sides, and we got more or less a very similar percentage ratio. The advantage of the X-Ties, as you have seen in the presentation, is the fact that they are an industrial product that is easy to apply, and so it saves a certain amount, a significant amount of time in securing the lid to the bottom due to its special shape. So it's about a reasonable 20% faster installation as well on flat. There is, okay, yes, this is another interesting question. You show a reduction in CO2 of about 82%. Can you explain that? Well, the reduction in the carbon dioxide emissions is based on an independent study done by a consultant. The consultant what basically put together was a mix of what is, let's say, part of the life of a gabion or an alternative structure, in this case the riprap or a Rhino mattress. By doing the analysis, we had to take into account the, as we said, the materials, so the supply of these materials, considering that rocks come from quarries, so there is the blasting effect, there is a number of operations, the transportation by truck. Larger stones require more trucks because of the voids, and they cannot, let's say, and the weight itself. So the combination of this, including the production of the steel material, which comes from a factory. So again, the whatever is part of the, from electricity, all the processes in the industrial process of the production of Rhino mattresses have been accounted and summed up together. So and then there is, of course, the installation time, the use of a larger crane, a small crane, etc., etc. So all these details combined together formed, in terms of numbers, an 82% difference between the installation of riprap and an installation of a Rhino Mattress Plus. Well, I see there is a number of other questions. I'm really flattered. What we could do is actually answer all of your questions via email. I will be more than happy to do this. So for this time, I'd like to thank you for your time, for your assistance, for your questions, sorry, and we'll be more than glad to assist you with any projects or any questions that you might have. Thank you again.